So sometimes we interpret p-values on a continuum and just describe the strength of evidence, but anytime we turn it into a dichotomous decision, reject or fail to reject, it's possible that we could come to the wrong conclusion based on the data. So let's say that the null hypothesis is actually true. Then hopefully we would fail to reject it. That would be the correct decision in this case. But what if the null was true and you actually rejected the null? This is called a type 1 error. So even though it's called an error, it doesn't mean that you did anything wrong. It just means that because of sampling variability, the sample data that you had led you to the wrong conclusion. On the other hand, what if the null hypothesis is false? So in this case, the correct decision would be to reject the null hypothesis. But it's possible that you might fail to reject, and that is creatively named a type 2 error. Some people like to see it in the table, some people prefer to see it in sentences, so I'll do it both ways. A type 1 error occurs when researchers reject the null hypothesis, when in reality the null hypothesis is actually true. Whereas a type 2 error occurs when researchers fail to reject the null hypothesis, when in reality the null hypothesis is actually false. Or of course we could also write it that the alternative hypothesis is true. So type 1 and type 2 errors both have their own consequences. Let's think about this example. A marketing team at a credit card company would like to offer customers double airline miles if they charge at least $1,000 per month to their card. However, they decide this incentive will only be worth promoting if at least 20% of customers below the $1,000 threshold increase their monthly spending to over $1,000. So in this case, our null hypothesis is going to be that the proportion who would increase their spending really is equal to 20%. Remember, the null hypothesis always has an equal sign in it. And so in that case, we've decided that it's not worth it, right? Offering the incentive is not worth the cost. Whereas the alternative hypothesis is that more than 20% will increase their spending. And in that case, we've decided that it is worth it. So a type 1 error in this context means that we would reject the null hypothesis and conclude the alternative. So we would conclude in this case that the proportion who would increase their spending is greater than 0.2 when really the null hypothesis is true. So when really it's equal to 0.2. In other words, we think it's worth it to promote the double miles program when it actually isn't. So the consequence of this particular error is that we would promote the double miles program believing that it's worth it, when in reality it isn't worth it. So that would be the cost of a type 1 error. A type 2 error occurs when we don't have enough evidence to reject the null. So we do not reject p equals 0.2, when really the proportion is greater than 0.2. So the double miles program actually was worth it, but we weren't able to prove that based on our data. So the consequence would be a missed opportunity. This is a pretty common interpretation of a type 2 error. So it's a missed opportunity to increase customer spending. So when we don't have enough data to draw our conclusion, sometimes we miss out on opportunities. So how are these errors related to the significance level alpha? So it helps to think about how this rule works, right? We reject the null hypothesis anytime the p-value is less than your alpha level, right? That's generally how we use significance levels. So if you think about it, it's going to be easier to reject the null when the alpha level is high, right? You can sort of think about it like limbo, right? The higher the bar is, the easier it is to get under it. So it's going to be easier to reject the null when the alpha level is high. So if your alpha level is high, you're going to be rejecting the null more often. So this also means if you're rejecting more often that you're making more type 1 errors, right? Because type 1 errors happen when you're rejecting the null and it's actually true. So if you make it easier to reject the null, you're going to end up with more type 1 errors. But the trade-off is, if you're rejecting more often, that you're going to have fewer type 2 errors. Right? Type 2 errors occur when you don't have enough evidence. If you sort of change your standard so that you don't require as much evidence to draw a conclusion, you're not going to have as many type 2 errors. So setting the alpha level is a trade-off. You can't just say it's good to have a high alpha level or it's good to have a low alpha level. It really depends on the circumstances and what the consequences of the different errors are. And you'll think about that in your next activity.